We're now on to round 2 of the Perse Coding Challenge, and we're just going to talk about the format, the level of questions, and the topics that you need to know for round 2. So most of the questions should be completed within, that given time scale. They will range in difficulty, but each question is worth an equal 10 points. So that's definitely worth remembering, because sometimes you might find one question easier than the other, and you might prioritize that question over the harder one because they're both worth the same number of marks. So this format is designed with the intention that it encourages teams to divide and conquer and includes a younger programmer to aid development who can concentrate on the easier questions. So level 1 questions can be usually solved in under 10 lines of code, sometimes a lot less, and they will typically focus on some basic text or number processing, right? They give you 2 pieces of text, they ask you to put them together, concatenate them, or maybe change a few letters. They give you a number and tell you to multiply it, simple stuff. Level 2, we start getting to the short programs, and we use functions and arrays. So a tiny bit more difficult, but not really. Level 3 questions are kind of easy versions of the Olympiad questions, if you've ever tried those. Olympiad level 1 questions, at least. And usually we would have a bit of iteration and selection. So we'd be using some for loops, while loops, and if statements. And this is quite an important point. Some of the test cases might require a time-efficient solution. So you might be, for example, given a question, let's say, to print the numbers from 1 to 20 on each line. So it goes 1, 2, 3, 4, 5, 6. You could, of course, do print 1, print 2, print 3, and keep going. But firstly, this is not efficient when it comes to your time, and you are timed in the challenge. So it's very important to try and think of easier solutions, ways that, where I could just do for I in range 20, print I. Well, it's going to be 1 to 21, actually. Sorry, that's my mistake. And I print I, and that actually prints out all the numbers from 1 to 20 exactly as I want. Second of all, it's not just the efficiency of your time, but also how it runs. So that first program might be more difficult for the computer to run. And when you're running the test, so when you submit your answer and it runs the test, even though your solution actually does exactly what they have asked you to do, it might fail one of the tests because it doesn't meet the efficiency requirements. They need a solution that runs quicker on the computer. So that's something to bear in mind because it's very, very important. And then finally, level 4, and these are easier versions of the Olympiad level 2 or 3 questions, and they focus on modeling questions. So for example, short game simulation, some algorithmic complexity, and in these, tests would time out if a less efficient method is used. So they actually give you a time limit, not to complete the question, but for the computer to run your solution. So it's 4 seconds of processing time. If you write an inefficient solution that requires more than 4 seconds to run, you will lose marks. So that's also very important to remember. All right, but we can discuss efficiency in more detail in time. So just to give you a summary of the topics that we actually need to know for round 2, and we don't know quite a few of these. So it's going to take us some time to work through and do, but yeah, just to get a sense of it, so we have line problems. We don't know about stacks or recursion. We're going to be doing that. Simulation problems, we're going to be covering that, as well as binary trees, Dijkstra's algorithm. We've done breadth first search, but there's a there's a similar algorithm that also looks through grids, mazes, binary trees, and it's called depth first search. We've looked through some maze problems, but we also want to expand on that knowledge. We want to look through heaps, hash tables, prefix sum, and dynamic programming. So quite a few topics, and these are considered high-level topics, so they do require some time to learn. So there are many advanced data structures and algorithms that we need to learn for round 2, and this can be quite challenging. Now, all of these are actually exciting and they're fun to do, but for now we have moved beyond Python-specific topics and are focusing on general data structures and algorithms that can be applied across various programming languages. So it's not just that we're learning Python, but we're actually learning how to program, and we're learning more about the underlying data structures in general, but we are still going to be using Python to do this. And one of these, and this actually ties in very well with what I was speaking about in terms of efficiency of a program, the one we're going to do next is time and space complexity. And this gives you a sense of how complex your program is. By complex, we mean, how much time does it take to run? How much space does it take up? So it's very, very important that we do this. We're going to do this next Saturday. So round 2 coming up, I believe it is coming up in March, early March. So we have quite a few topics to cover. They are more advanced topics, so we should really be excited because we're learning some real advanced stuff, and that's really nice. I'm looking forward to it, honestly. These are really nice topics. And as always, we're going to be looking through some past questions. We're going to be trying out different. I think I'm really going to try with some questions to draw up different solutions, have one that's efficient, one that's inefficient, and compare the two. Maybe see even if we lose marks when we submit the inefficient solution. And yeah, as I said, next week we'll start talking about time and space complexity using the big O notation.